Physics is amazing. You may not realize it, but the application of physics is all around us. Some people only see physics as another math or science discovered by Newton when an apple fell on his head, but it's so much more than that. Physics is the combination of math and science together and applied to everyday situations in the world. Having an understanding of physics can help you understand anything from how long it will take before the box will fall on Bob to the amount of energy produced in a nuclear explosion. One application of physics that can be seen in everyday life is deciding a safe speed limit. Okay, so let's say we have a 2,630 kilogram SUV driving down the road at 45 miles per hour. When suddenly there's a bend in the road, and let's say this curve has a radius of 30 meters. With this information, we should be able to find out how fast the car can go to travel safely around the bend. First things first, we need to create a force diagram. We're going to have normal force, the force of gravity, and the force of friction pulling the car towards the center of the circle. Now that we know our forces, we can start filling in the blanks. Okay, so we know that force of gravity equals mass times gravity. And we know that the mass is 2,630 kilograms, and gravity is 10. So that gives us a force of gravity of 26,300 newtons. Next, we can determine the normal force. Since there are no other forces acting upon the car up or down, we are able to state that the normal force is equal to force of gravity. So normal force is also equal to 26,300 newtons. Finally, we must figure out the force of friction. The equation for force of friction is force of friction equals mu Fn. Since the normal road has a mu of 0.7, we'll use that as our constant. Now we plug in the numbers, so force of friction equals 18,410 newtons. To determine the safest speed to travel around the curve, we'll use the equation force of friction equals centripetal force. And if centripetal force equals mass times velocity squared divided by the radius, then force of friction equals mass times velocity squared divided by the radius. Now we can plug in the numbers and we get a velocity of about 14.5 meters per second, or about 32 miles per hour. So for this car to travel safely around the curve, it must slow down from its original speed of 45 miles per hour to 32 miles per hour. If he did not slow down, the force of friction would not be strong enough to keep the car on the road, causing it to slide off on a tangent to the point where it lost its traction. Being able to calculate and understand this information has allowed me to see the world in a new light. I now do not just view speed limits as some meaningless number that was randomly thought up and put on the road. I know it's much more than that. Through learning this information, I have also learned to love physics, and I have begun to look into the field of civil and environmental engineering and hope to study it one day in college. Being able to fully understand this problem, and others like it, is important to know because they allow the State Department of Transportation to calculate the appropriate speed limit for specific roads. So next time you see a sign that says slow down for the curve, don't just ignore it, because it's there for your safety. And if you do ignore it, you may just end up flying off the side of the road. I hope you enjoyed my video, and I hope that it helped you learn more about how physics applies to the world around us. I would like to give special thanks to my dad, my mom, and my brother for helping me film and edit this video, to my physics teacher for helping me solve the problem, and to my calculus teacher for making me do the project, which made me happy in the end.